Welcome to Science by PK. Today we're diving into the life of a star, how it forms, how it lives, and how it meets its end. Stars are like celebrities of the universe, bright, big, and dramatic. But just like celebrities, they don't last forever. Some go out quietly and others go out with a literal explosion. So what makes a star? Let's start at the beginning. Birth of a star, the cosmic nursery. Stars are born in massive clouds of gas and dust called nebulae. Think of a nebulae as the universe's baby-making fact, giant clouds of space stuff just floating around, waiting for something to happen. But space is lazy, so it needs a little push, maybe nearby supernova explosion or two gas clouds colliding. That causes gravity to start pulling the gas and dust together, squishing it tighter and tighter. As the cloud collapses, it gets hotter. And when I say hot, I mean hot. Millions of degrees. At this point, we have a protostar, a baby star, and that's still figuring out how things work. It's kind of like a high schooler burning energy, but not quite ready to shine fully. If it gathers enough mass, nuclear fission kicks in, and boom, it's a real star now. The main sequence, the prime of a star's life. Once a star's fusion, smashing hydrogen atoms together to make helium, it officially joins the main sequence, or phase. This is the longest and most stable part of a star's life. Think of it as adulthood, paying bills, going to work, just existing. Our sun is a main sequence star. It's been burning for about 4.6 billion years and has another 5 billions to go for. For stars much bigger than the sun, this phase is much shorter. The bigger and hotter a star is, the faster it burns through its fuel. Kind of like sport cars guzzling all the gas compared to a little hybrid. What happens when the star runs out of fuel? Stars don't live forever. Eventually, they start running low on hydrogen, and this is where things get interesting and a little dramatic. What happens next depends on the size of a star. Small stars like the sun, a peaceful retirement. When a small or medium-sized star runs out of fuel, it swells into a red giant. Basically, it's having a mind-life crisis and expanding all directions. When our sun reaches this phase, it'll expand so much that it will likely swallow Mercury and Venus. Earth, yeah, we're toast. After this red giant phase, the outer layers of the star drift away, forming planetary nebula. What is left behind is a white dwarf, a tiny super hot core that slowly cools over billions of years. Eventually, when it stops glowing, it becomes a black dwarf, a dead star. But that process takes longer than the current age of the universe, so no black dwarfs exist yet. Big stars, they go out in supernovas. Now if a star is much bigger than the sun, at least 8 times its mass, it doesn't go out peacefully. No retirement, no white dwarf, just boom. Massive stars go through different fission stages, burning heavier and heavier elements like carbon, oxygen, and even iron. But once iron forms, the star is done. Iron doesn't produce energy when fused, so gravity wins and the core collapses in less than a second. That collapse triggers a supernova, one of the most powerful explosions in the universe. For more information about that, check out my other video about supernovas. A supernova is so bright it can outshine an entire galaxy for weeks. This explosion scatters heavy elements into space, meaning the iron in your blood and calcium in your bones is literally made of ancient stars that exploded billions of years ago. You are quite literally made out of stardust. Pretty cool, right? After supernova, the core can turn into one of two things. 1. A neutron star. Imagine a city-sized object packed with more mass than the sun. It's so dense that a sugar cube-sized piece of it would weigh as much as Mount Everest. Some neutron stars spin super fast, blasting beams of radiation. These are called pulsars. Number 2. A black hole. If the star was really massive, gravity just keeps collapsing the core until it becomes a black hole. This is where physics go goes, I give up. The light itself can't escape. If you fall in, well, good luck. You'll get stretched and stretched and stretched. But what about failed stars? Not every star gets to shine. Some objects start forming like stars, but don't have enough mass to ignite nuclear fission. These are called brown dwarfs, or failed stars. They're kind of like universe's rejected audition tapes. Too big to be planets and too small to be real stars. The final takeaway: stars live wild and dramatic lives. They're born in a nebulae, shine for millions or billions of years. They either fade out as white dwarfs or explode as supernovas. Some turn into a neutron star, some become black holes, and some never get to start. So next time you look up at the night sky, just remember, you're looking at billions of stories, each star with its own fate. And who knows, maybe the atoms in your body came from a star that exploded long before Earth ever existed. That's the cycle of a star. If you like this, make sure to like, subscribe, and hit the notification bell to Science by PK. If you hit the subscribe button, that would really mean a lot to me, and we'll see you on the next one.